Welcome to my channel. In this video, we are going to discuss deadlock chapter, in that a banker's algorithm. How to avoid the deadlock? If I have a single instance of resource type, we can go for a resource allocation graph. If we have a multiple instance of resource type, we can go for a banker's algorithm. Not bakery algorithm. Banker's algorithm. Banker's algorithm we use whenever we have a multiple instance. Each process must a priori claim the maximum use. When a process requests a resource, it may have to wait if those resources are not available presently. When a process gets all its resources, it should make use of those resources and it should return them in a finite amount of time. Recall what we have discussed, how to write the save sequence. I have 3 available resources. I have considered only one resource. Name is A. Resource type A. Available is presently 3. The requirement of P1 is 2. Currently holding 2. Maximum it needs 2. I can give it to the P1. So it will give back to the 2. And presently available are 3. Totally will become 3 plus 2, 5. So like that I can go for next P0. It is already holding 5. It needs a maximum 5. And when it completes execution, it will return 5 back. Total will become 10. Then I can give it to the P2, which needs 7. It will give back to the 2. Total will become 12. This case I have taken only A as a resource type. Similarly, I may have more than one resource, A, B, C, like that. So now in banker's algorithm, we are going to discuss like this. So what are the data structures I need? That I am going to discuss in the next slide. I need available, whether I need a matrix or a array, I have to think. Available, I need a array, or I can say a vector of length m. What is the meaning of this? Available of j equal to k. There are k instances of resource type rj are available. In this case, p0, p1, p2 we are writing a processes. Resource types I have a, b, c. And how many instances are available? A resource 3, B 2, C 3. Like that you have to understand. Maximum, whether I need an array or matrix data structure. I need the data structure matrix because for P0 I need to maintain, P1 I need to maintain, P2 also I need to maintain. Similarly, I may need an allocated matrix. I may need a need for P0, for a P1, for a P2. To maintain that, I need another data structure which is of n cross m matrix. You can pause and go through. Data structures for the banker's algorithm, whatever I just now told, completely once again it is mentioned in this particular slide. You can pause this and just go through this particular slide and try to understand. Let us try to write down what is the need of P0. P0 is already allocated to the 0 1 0. Don't read, it is a 753, something like that. It is called 753. 7 of the type resource A, 5 of the type B, and 3 of the type resource C. Now how many P0 needs A, B, C? It is equal to, just pause it and try to write in your notebook and compare. This is 743. How? Simply maximum minus allocation you have to do. Maximum is how much? 753. Allocated already 0 1 0. You will get a remaining is 743 is the need. Save sequence, how to find? We have already discussed this. Available is 3. I will take this as a work. And finish. I have not yet completed P0, P1, P2. I will take it as a false. First I will try this 3 with a P1. And then I will add this 3 to the allocated. Same thing I am writing as an algorithm. If need is less than work, then work equal to work plus allocation of I, finish of I equal to true. The same thing I had done. For example, 3 are available, I am giving it to the P1, and P1 I will make it as a now completed. Then this holding 2 count instances will be given back, total will become 5. That's a work equal to work plus allocation. Repeat this until and unless we get to complete all the processes. And this is for one resource. Similarly, we can do it for more than one resources you may have. Now, this is safety algorithm. Just pause the video, go through. Let work and finish be a vector of a length m and n respectively, and work equal to available. Just now you took for a one resource, similarly for many. Finish of I equal to false because I have not yet taken any process. Find an I such that both finish of I equal to false, need is less than work. We did it in the previous case. P1 needs only 2 and I had already 3 in the hand. It is not yet completed. So like that, this is the second case. Then once if you find such that for such a process, what you have to do? Do it work equal to work plus allocation, finish of I equal to true. Go back to the step 2. This you repeat until unless all processes are over. If all processes are over, then I can say it is a safe state. Otherwise, few processes are remaining, then the process is not in the safe state. Resource allocation algorithm. What it does, request of I equal to request a vector for process Pi. If request of I of j equal to k, then process Pi wants key instance of resource type Rj. When the request for the resource is made by process Pi, the following action are taken. What are those actions? You just see it. Some process is requesting for some resources. Actions are like this. If a request is less than need, go to step 2. It cannot ask more than that. No? Otherwise, there is an error condition since process has exceeded its maximum claim. If a request is less than available, go to the step 3. Otherwise, Pi must wait since the resources are not available. Pause the video, just go through step number 1 and step number 2. Then the step number 3, pretend, I have underlined. Pretend to allocate the requested resource to Pi by modifying the state as follows. What I do, as if I have already allocated, like that I will make all the changes in the data structures. For example, available I will reduce it, allocation I will increase it, and need I will reduce it. Then I will check whether the system will remain the safe or not. If it is a safe, the resources are allocated to Pi. If unsafe, what I have to do? Pi has to wait and old resource allocation state is restored. All these things should be undo you have to do. So safe, how to find out? Just now in the previous slide we had discussed how to find the safe sequence. That is the algorithm we use here. Take one simplest example of Banker's algorithm. In the system I have 5 processes P0 through P4, 3 resource types A, B, C. A is having a 10 instance, B is having 5, C is having a 7. Now can you write the available? Maximum is this much. And can you write the need? For example, P0 already allocated to the 0 and 0. Maximum it needs 7, 5, 3. So what is the need? Before going to the need, you can write available. I told maximum is 10, 5, 7. In that already allocated are this much. Remaining are how much you have to write on available. Pause the video and try. When I added all this, allocated, it becomes a 725. How many maximum I have? 10, 5, 7. When you minus it, you will get a 3, 3, 2 is available. Just do it. You can pause the video. So whatever I just now shown, the same thing I am showing you. 10, 5, 7 is the maximum. And allocating is a 725. I am subtracting. I will get a 332. Never read it as a 332. It is a 332. A 3, B 3, and C is 2. Now I have to write a content of a need. How to write? Need equal to maximum minus allocated. Maximum is given, allocated is given. Just subtract, you will get a need. You can pause the video. Just write down that need. Now, whether the system is in safe or not, I have to find out. All of us know how to find the safe state with the safe sequence. Once if I find a safe sequence, I can say system is in safe state. Otherwise, no. I have a 332. These are allocated. Needs are this. Now 332 available. To which process I can allocate so that need should be less than 332. I can allocate to which process? Pause it and decide. Yeah, I can allocate to P1 because it needs only 1, 2, 2. Sir, can I allocate to P3? Yeah, you can do it. But if you get one safe sequence, I can say system is in safe. You may get more than one safe sequence. Now let me take one. Say 3, 3, 2 are there, I am allocating to the P1 and it will return how many back? It needs 1, 2, 2. Already allocated are 2, 0, 0. So you will get back plus 2, 0, 0. Plus 2, 0, 0 if you do, you will get a 5, 3, 2. So like that, I will allocate to the P3. P3 needs only 0, 1, 1. And I will get total available will become 7, 4, 3. Like that, later I will allocate to the P4. Then I will allocate to the P2. Then I will allocate to the P0. The safe sequence what I got is P1, P3, P4, P2, P0. You may get more than one safe sequence. Should I try all? No. Even if one safe sequence is there, I can say system is in safe state. So check that. The request is available, less than or not available. 102 is the request, 332 are available. Can we grant the request? So what I have to do? Now 102 is the request, even though less than this, if I have to check after allocating, I have to make all the data structure changes. I have to update allocated. I have to update need of that particular process and available. Then I have to find out a safe sequence. Now I have tried keeping this allocation need available. I got P1, P3, P4, P0, P2 as a safe sequence. So again, say there is a request for 330 by P4, can be granted or not? Just check on that. Can request for 020 by P0 be granted? Don't say 020 are available, sir, I can do it. No. How to do? Think that you are allocated. Make changes in all this allocated, need, available. Find the safe sequence. If safe sequence is available, then you can allocate. Otherwise, don't allocate. Now compare the previous. Previously I had a 200. Now available were 332. Now it is a 230. So take this as a homework and do it. And summary. States of process are ready, run, wait. Deadlock means waiting for each other. Each vehicle waiting for another vehicle to go back. So please remember here this diagram in day-to-day life also. So wait for each other. It's not wait for each other. I have taken in the second video. In day-to-day life is also most of the time we wait for others to talk, others to speak. So it's better to roll back you only and you only start, so that there will not be any deadlock. Instead of waiting for each other, you can become a made for each other. This is the reference book which I referred, and for more information you can visit these links. Thanks for watching this video. Share this video if you like, and please subscribe this channel. Thank you.